Hello, welcome to today's lecture. We're going to start chapter 5, integrals. So we are on 5.5. We're going to define integrals and different techniques in taking the integrals of functions. So let's review a little bit, recall that. Suppose you have a function like f of x equals to x to the n. So we learned that how to take the derivative of this function. The derivative of this function is defined this way. We try to reduce the exponent. So we say that f prime of x is equal to n times x raised to n minus 1. The opposite operation of taking the derivative of a function is called taking the integral of that function. So this is the derivative. We define anti-derivative or just the integral of this function. The integral has notation. Integral, this is the meaning of sum, or the integral. For function f of x, it's denoted by f of x, and since you are taking the integral, taking the sum over variable x, you put dx next to it. So for this function, the integral or antiderivative of x to the n, dx is defined this way. This is x raised to n plus 1 divided by n plus 1. Plus, you add a constant of integration to this definition. So this is just a constant, and you call it the constant of integration. So look at the difference between the derivative and antiderivative or the integral of the function. When you have exponent n, by taking the derivative, you drop the original exponent and you subtract 1. When you're finding the antiderivative, you add 1 to the original exponent and you divide it by n plus 1. Exponent plus 1. That's the main difference between these two. N plus 1. So let us write this here on the right hand side as you continue. So if you have a power function y equals to x to the n, its derivative y prime is n, x to n minus 1, you subtract 1, and the integral of x to the n dx is equal to x to n plus 1 divided by n plus 1 plus constant of integration. Next function, suppose you have a constant function. Y is equal to k, just a constant function, a horizontal line. So the derivative of this function, if you take the derivative of any constant function, the slope of the line is 0, so the derivative or instantaneous rate of change is 0. But for the integral or antiderivative, you have the integral of k dx with respect to variable x, we get k times x plus c. Next formula, if you have y equals to e to x, if you have exponential function e to the x, remember that the derivative of exponential function e to the x is the same as sub e to the x. So the integral of e to the x dx is e to the x plus constant of integration. Integral of dx divided by x is defined as ln of absolute value of x plus c. So these are important formulas how to find the integral or antiderivative of a function. We already learned about the derivative. Now here you have the antiderivative or the integral of these functions. Okay, let us go over some examples if you're comfortable about these formulas. Example. This example says, find the integral of 4 dx. There we go. We have some functions here. X to the n, k as a constant function. Okay, here I have y equals to k. You know that? The integral of k dx is kx plus constant of integration. In this example, k is equal to, so just follow the formula. The integral of 4 dx is 4x plus c. So let me give you a note. Note that if you see integral of just dx, what is the k? So this guy can be written as the integral of 1 times dx. So dx, the meaning of dx, it means that you have 1 as the constant times dx. So in this example, k is equal to 1, so the integral of 1 times dx is 1 times x plus c, or x plus constant of integration. Next example. So in this example, you have the integral of x to the third dx. So what do we have here? Here we have a power function, x to the third, and we're following the formula for power function. We know that the integral of x to the n dx is x raised to n plus 1 divided by n plus 1 plus constant of integration. So x to the third, it means that n is equal to 3. Therefore, the integral of x to the third dx is x cubed 3 plus 1 over 3 plus 1 plus constant of integration. If you simplify this, the integral of x to the third dx is equal to x to the fourth divided by 4 plus c. Or you can write it this way. F4 times x to the fourth plus constant of integration. Both of them are x. Next example for you. So here you have x raised to 2 thirds. Again, you have x raised to an exponent. X raised to 2 thirds is x raised to n, so n is 2 over 3. We know that the integral of x to the n dx is x to n plus 1 divided by n plus 1 plus constant of integration. We also know that n is equal to 2 thirds, so let us follow the formula. 2 over 3 dx is equal to x raised to 2 over 3 plus 1 divided by 2 over 3 plus 1 plus constant of integration. You're done with calculus part, the rest is algebra. This is equal to x raised to 2 thirds plus 3 over 3 divided by 2 thirds plus 3 over 3 plus constant of integration. You get x raised to 5 thirds divided by 5 thirds plus c, which is equal to 3 over 5. I'm flipping the denominator and x raised to 5 thirds plus constant of integration. Next example for you. So here now you have 1 over x to the fourth dx. 1 over x to the fourth dx. Very well, it's not very much like x to the n. I have to make a little bit adjustments, a little bit changes for this function. So since 1 over x to the fourth is x raised to negative 4, on the denominator I have positive exponent, on the numerator I have negative exponent. Now I can see x raised to n is a negative exponent. That's absolutely fine. You can have positive exponent, you can have negative exponent, that's okay. So let us follow the formula. The integral of x to the n dx is x to n plus 1 over n plus 1 plus constant of integration. So the integral of 1 over x to the fourth dx can be written as x to negative 4 dx, which is equal to x to negative 4 plus 1 divided by negative 4 plus 1 plus constant of integration. Okay, almost done. So this is equal to x to negative 3 divided by minus 3 plus constant of integration. You can leave it as it is, or you can write it as 1 divided by negative 3 times x to the third plus c. Or you can write it as negative a third times 1 over x to the third plus constant of integration. All of these formats are absolutely fine. So let us make it more interesting. suppose you have this integral. You have integral of 4, so 6 times x squared dx. Very well. So I have x squared, I have a coefficient like 6 multiplied by x squared. What can I do? I can just take this coefficient 6 and write it in front of the integral. So this is 6 times the integral of x squared dx. X squared, x to the n is equal to 2. This is equal to 6 times x to 2 plus 1 divided by 2 plus 1 plus constant of integration. I have 6 times x to the third divided by 3 plus constant of integration. Now you're done with your calculus. Let us simplify this using algebra. You get 2 times x cubed plus c constant of integration. Next example for you. More interesting examples are coming. So here you have the integral. Now we have a polynomial, a combination of some terms. 4x squared plus 8x minus 7. Let's put them in parentheses to make sure that all of these terms are inside the integral. And our goal is to find this integral. How many terms do we have? We have 1, 2, 3 terms. This is your first term. This is your second term. And this is your last term, the third term. So we're going to take the integral of each of these separately. Take the integral of each. So the integral of 4x squared. This is very similar to x to the n, and as you can see, n is equal to 2. This guy has degree exponent 1, so n is equal to 1. This is just a constant, like y equals to k. You have to follow the formula for y equals to k. So constant y equals to k, so your k is negative 7. Very well. The first integral is 4x raised to 2 plus 1 divided by 2 plus 1 plus 8. We have a coefficient 8. X raised to 1 plus 1 divided by 1 plus 1 minus 7. X plus constant of integration. So here you get 4x to the third divided by 3 plus 8. X squared over 2 minus 7x plus constant of integration. You can rewrite this, you can simplify this. You can write the first term as 4 thirds, x to the third plus 4x squared minus 7x plus constant of integration. Very well. Next example for you. So here we have the integral of the first term is 5 x to 2 thirds minus constant 4. How many terms do we have? We have 2 terms. The first term is 5x to 2 thirds. This is your first term. This guy is your second term. The first term is in the format of x raised to an exponent. As you can see, n is equal to 2 terms. And the second term is constant function k is equal to minus 4. Very good. Let's take the integral. The first integral is 5 times x raised to 2/3 plus 1 divided by 2/3 plus 1. And here you have minus 4x plus c. You're done with the calculus part. The rest is algebra. Let us take the common denominator. For this, you get x to 2/3 plus 3/3 divided by 2/3 plus 3/3 minus 4x plus c. So this is 5 times x raised to 5/3 over 5/3 minus 4x plus c. If you flip this fraction, you get 5 times 3/5 x to 5/3 minus 4x plus c. So you can cancel out 5 and 5. The final answer is equal to 3x to 5/3 minus 4x plus constant of integration.